So our next lesson is lesson 5 on exponents part 1. There will be another exponents part 2, which is probably putting it all together and doing complex examples using exponential laws. So we're going to be talking about exponent laws part 1 here. We're going to get started with product of powers. So here in this case, we have 2 cubed. The meaning of 2 cubed is 2 times 2 times 2. And the meaning of 2 to the 4th is 2 times 2 times 2 times 2. So again, if you have the expression 2 to the 4th, this again is not equal to 2 times 4, but it's equal to 2 multiplied to itself 4 times. So again, this is not equal to 8, but it's equal to 16 because it's 2 multiplied to itself 4 times. So if you're multiplying 2 cubed times 2 to the 4th, we're actually going to get 7 2's here, which means the answer would be 2 to the 7th. So to probably think about what would be the rule then, if you are multiplying an expression with the same base, what do you do with their powers? Well, it looks like the powers are being added. So in this case then, this would be 3 over 4 to the power of 7. What is your general rule here then? If you have a raised to the power of m and a raised to the power of n, your expression there would be just adding m and n. So that's your first. It's called the product of powers. You don't need to remember the names there, but know that when you're multiplying expressions with the same base, you're copying the base and you're adding the exponents. What about if you are dividing? I'm just going to use this example here. There's 9 7s. Ooh, I have to write all these 9 7s, huh? 2, 4, 6, 8, 9. And the bottom has 7 7s. So that's... okay, there we go. Now, when we're dividing, 7 divided by 7 is actually equal to 1. So we're actually canceling all the 7s here. And 2, 3, 4, 5, 6, 7. 7 7s on top as well. So what we're left with is actually just 2 7s right here. So in this case, the answer to this one is actually 7 to the power of 2. So when we are dividing, what do we do with the powers? As long as the base is the same, we actually subtract the powers. We don't divide the powers, but we subtract the powers. So your rule here then is a to the m divided by a to the n is actually equal to a to the m minus n. Again, we're subtracting your powers here. And what about if you have a power of a power? Take note here that you have an inner power and an outer power. So in this case, if you have 2 to the 5th raised to the 3rd exponent, then you can say that you have 2 to the 5th 3 times actually, like this one here. And now we know that 2 to the 5th multiplied to 2 to the 5th and another 2 to the 5th, that's actually equal to 2 to the 15. So you can probably see what is the rule. What do we do with the inner power and the outer power? We actually multiply them. So in this case here, we have negative 3 raised to the power of 2 times 4 is 8. So your rule here is a to the m raised to another power of n. So you have an inner and outer exponents. The answer would be a to the m times n. Okay? And what about if you have a power of a product? If you have kind of many things or 2 things inside and then they're all raised to the same, to an exponent. So this is the case where you have a squared b to the 5th, and actually there's 3 of them because it's cubed, right? I'm going to try to fit it in here. Yeah, so now we can collect a squared, and a squared. That's actually a to the 6th. And all the b's, b to the 5th, b to the 5th, and b to the 5th, that's actually b to the 15. So what we're actually doing here is we're kind of distributing and multiplying the power. 2 times 3 is 6. 3 times 5 is 15. So what would be our rule here? Rule here would be a to the m, maybe b to the n, or any other expressions there. Raised to the power of p, that would be a to the m times p, and then b to the n times p. So they're further multiplied to every single factor inside your exponent. And the next one here, oh, I want to do this example for the next one here. So if we have 4a cubed b squared, what we're actually doing is we oftentimes forget about the 4. We have to do 4 to the 4th, and a to the 12, b to the 8. And 4 to the 4th is 4 times 4 times 4 times 4, which is 16 times 16, which gives us 256, a to the 12, b to the 8. And what about if you have a power of a quotient? So the same is true here. We're going to have a to the 9th over b to the 15. We're going to distribute the power to the top and also at the bottom. So in this case, we have a to the m over b to the n, all raised to p. So this is a to the m times p over b to the n times p. Oops, I wrote the p wrong there. All right, so what about if we have a power of 0? So let's do a little exploration here. If you have 2 to the 1, that's actually equal to 2. 2 to the 2, and that's actually equal to 4. And I'm going to add here 2 to the 3rd is equal to 8. So as you can see, when we go down the power 3 to 1, and our next one would also be equal to the 0. When we go down from here to here, 8 divided by 4 is actually 2. So when we divide these two numbers, actually no, 8 divided by 2 is equal to 4. And then 4 divided by 2 is equal to 2. And the trend there is actually dividing by 2. So this guy should be equal to 1. And you can explore also 3 to the 1, 3 to the 2, or the second power, 3 to the third power, and then 3 to the 0. They're all going to be equal to 1. So this expression here will be equal to 1. Therefore, any expression raised to the power of 0 is always going to be equal to 1. So let's do a few examples on example 2 here. Let's do letter C. So when we are multiplying these expression here, what we can do first is multiply your numbers. 7 times -3 is -21. And then I can put together a squared times a here. That's actually a. There's 2 a's here and 1 there, so that's a cubed. And for the b, that would be b to the 11th. Where did I get 11? 5 and 6. And if there are no more other expressions that you can put together, and that would be your answer. Okay, let's look at letter F here. So for letter F, we're going to take care of this one first and this guy as well, and then put them together. So let's write 3ab for now. And then this 2 here needs to be distributed to every single thing inside those brackets there. So that's 2 squared, a squared, and b squared, all divided by, oh, take note the 2 is not part of the brackets there. So 2 would stay, and 3 would be distributed to a cube, and then b cubed. And then we can put them together. This would be 3, and 2 squared is 4, so that's actually 12. And then we have a and a squared, so that is actually equal to a to the 3rd power. And then we have b and b squared, and that's also equal to the 3rd power, divided by 2a cubed b cubed. Now, or thinking about subtracting these numbers here, 3 minus 3 is actually equal to 0, so this becomes a to the 0, or we can just go ahead cancel that. That's just equal to 1. A to the 0 is equal to 1. This also cancels out because they're exactly the same expression. What we're left is actually just 12 over 2, or equal to 6. Let's look at example 3, letter C here. Now you can do a few things in letter C here. What you can do is simplify the inner expression first and then raise it to the third power, or you can distribute your third power here and then simplify towards the end. I prefer the first one just because if we simplify, we're going to deal with smaller numbers and then we can distribute the number 3. So let's simplify first and then we can put them all as a power of 3. So in this case, 16 and 20. What can you simplify or what can you cancel out from 16 and 20? 16 and 20 can be both divided by 4. So this divided by 4 is just actually 4. 20 divided by 4 is just actually 5. So this guy becomes 4 over 5. And if we look at the expressions on the your letter A here, the power is 2 and the power here is 1. So 2 minus 1 is just equal to 1. So here's one trick that I will teach you about doing division when you're doing exponents. You can think about subtracting them, but what you can also think about is here's 2 A's here at the bottom and here's 1 A at the bottom. Which A is more? Well, the A that's more in terms of power is the top. How many more? It's 1 more. So A to the 1 should go on the top. What about for B? B is higher on the top by how much? By 2. So B squared should be on the top. Nothing is left. Or you can think about obviously subtracting them. But that's one way to kind of prelude you or kind of introduce you to negative exponents later on. So in this case here, now that our expression is simplified, then we can say we can distribute now your third power. So 4 cubed, A cubed, B to the 6th divided by 5 cubed. And 4 cubed is 4 times 4 times 4, which is 64. A cubed, B to the 6th divided by 125. Now let's look at a couple of examples for example 4 here. This will be the last section on exponents part 1. If we're going to look at here for each of the following, find a value for m that satisfies the equation. So number 1, actually letter A here would be very easy. What is that number that you multiply to 2 to get 10? Your m there is equal to, you can do some mental math for the first one, m is equal to 5. But methodically speaking here, you can have A, what do we do with 2 and m? We actually have multiply each of them to 2 times m becomes 2m, and this would be A to the 10. Now that we have simplified or applied your law set of exponents, we can see that the A's are the same. Therefore, 2m should be the same as 10. And now we're left with, how do we solve for m? Well, we can divide both sides by 2. Your m there is equal to 5. Again, that's just an easy example because you can obviously find for m easily. And what about letter B here? Let's look at letter B. Letter B is multiplication. So what do we do with the exponents? We actually add them. So this becomes A to the 2m plus 8 is equal to A to the 14. And now we are putting them together, corresponding them together. That's A and A here. So it's gotta be that 2m plus 8 is equal to 14. And we're solving for m afterwards. How do we solve for m? Subtract both sides by 8. Some algebra here that we are reviewing. That's 2m equals to 14 minus 8 is 6. Divide both sides by 2. M is actually equal to 3. And let's do last example here. Let's actually do letter D. So for letter D, what we're doing on top, since we're multiplying, is we're adding them. So a to the m plus 2m, and then we're just putting a at the bottom, and that's equal to 20. We can't correspond anything yet because it's not a is equal to a, something of that expression. We need to put these guys together here. And we know that when we're subtracting exponents, when we are dividing expressions, we're actually subtracting their exponents. So a, well, I know what is m plus 2m, and that's 3m. And I know the exponent here is 1, so that's actually equal to minus 1. And then a to the 20. And now that they're both the same a here, we can just say that 3m minus 1 is the same as 20. Add 1 on both sides, and 3m is equal to 21. Divide both sides by 3, m is equal to 7. So that ends our exponent laws part 1. We're going to move on to exponent laws part 2 in the next lesson.